Hi there, I'm Hao, and this is just another video of me solving random number problem. So we need to count the node that is equal to the average of the subtree. So given the root of binary tree, you need to return the number of node, right? Where the value of the node is equal to the average of the value in its subtree. So in the example right here, it is the first node, right? The sum of all of the sub tree gonna be this, right? Divided by the number of node is 24, divided by 6, right? And 4, which is equal to the current node value, right? So that is count, right? Uh, this is also one node, right? 6 divided by 1, one node is 1, right? 1 divided by 1 is 1, right? 0 divided by 1 is 0, right? This is also count, right? So 5 plus 6 is 11, divided by 2 is 5, right? We need to round out to the nearest integer. Okay. So we can use post order traversal to solve this problem. So post order means we gonna process the root last, or we're gonna process the left and the right. Right? We're gonna count the total of node on the right, the total number of node on the left, right? And also the sum of all the node on the left and the sum of all the node on the right, right? And then we can calculate to see whether they are equal to the current node value. Right, so we can have a count of 0 here, and we can return the count again, right? And we can do post order of passing the root. Can do a post order equal to the node. So if the node is so we need to keep track of two things, right? This is our base case. When a node is null, we have to return two things, right? We get to keep track of two things. The first thing we need to keep track of is the number of node, right? And the second thing is the sum of the node, right? So if the node is null, which means that there's 0 node, and then the sum will be 0, right? Otherwise, we're gonna calculate the left and the right, right? Left sum and the right sum, right? But they will post order of node at left, right? Same for the right, right? So we're gonna process the root last, right? So this is post order. We process the left and then the right, right? I'm gonna return two things that I said earlier, the out and then the sum, right? So the total node count gonna be the left count, right? Plus the right count plus 1, right? Left count and the right count is what we are counting recursively, and the 1 here is gonna be the current node, right? Because we haven't counted the current node yet. Like plus 1 is plus 1 for the current node. The node sum will not equal to the left sum, right? Plus the right sum, right? Plus the current node value, right? Right. And then if matter floor of the node sum divided by the node count, right? And equal to the node value, we're gonna increment the counts, right? And then we can return the node count and then the node sum at the end. Like this. Right, so let's walk through an example here. Right. So we're starting at 4, right? We keep going left, right? Until here, looking left here. So it is null, right? So we return 0 and 0 here, right? 0 and 0 here, right? So the left count gonna be 0, right? We don't have the right count yet, and the left sum gonna be 0, right? Okay, so we finish processing the left, right? Now we need to process the right. The right is also no, so it also return 0, 0, right? So this means the right cow is also 0, and the right sum is also 0, right? So now we are at the node. We finished the left and the right. Now we're processing the node, right? So the node cow, right, gonna be the left cow plus the right cow, right? Plus the plus one. One is, which means the current node here, right? Plus one. So there's gonna be one, right? Node sum gonna be the left sum, right? Plus the right sum plus the node value, right? Which is 0 here, right? Which is 0, right? Right, and we take the node sum, right? We divide it by the node cow, right? And we flow that, and that is equal to 0, right? So 0 divided by 1 equal to 0, right? So that is equal to the node value, right? Which is 0 here. So we increment our count here is to 1, right? And then we have to return. What do we have to return? We have to return a node sum and a node count, right? So the node count gonna be 1, right? Node sum gonna be 0. Return up here, right? So we finished the left, right? Now we need to process the right side here, right? Right, this is also no, right? So it's gonna return 0 and 0, 0 and 0 here, right? So the count is gonna be 1, left sum and right sum is 0, less the node value is 1 here, right? It's gonna be 1, right? And 1 divided by 1 is equal to 1, right? So we increment our count to 2, and we need to return what? We need to return the cow and the sum, right? So we return the cow is 1, and the sum will be 1, right? We return up here, right? Now, the left count is gonna be 1, right? The right count gonna be 1. The left sum is still 0. The right sum gonna be 1, right? So the count gonna be 3 now, right? These three node 3, and the left sum plus right sum plus 1 gonna be 1 plus 1 plus 8. Oh, sorry, 0 plus 1 plus 8, right? So that is 9, right? And then 9 divided by 3 is 3, right? Is 3, and 3 is different than 8. Different than 8, which is another value here. So we don't increment the count, right? We keep it the same, and we have to keep returning, right? Up. So what are we returning here? We are returning the count and the sum, right? The count gonna be 3, the sum gonna be 9, right? And we just have to keep going for the right branch. Okay, so let's run this. Accept it, and thank you for watching.